Hello and welcome to the e-module on pumps. Let's take a look at the learning objectives of this e-module. At the end of the e-module, you will be able to explain what is pump and its uses, describe the working principle of a pump, classify the types of pump, describe positive displacement and centrifugal pumps in short, describe the components of a centrifugal pump, list the top 5 original equipment manufacturers in India. List the task to be done to maintain the pumps. Explain the work method statement for maintenance of pumps in detail. List the impact of business when there is a failure in pump. List the troubleshoot ideas that needs to be followed in case of pump failure. We have all used pumps in some form or the other in our daily lives, like the water pump, air pumps or fuel pumps. They play a very crucial role in providing comfort to us in many ways. Similarly, various types of pumps are used in industries and facilities for different functions or processes. A disruption in the water supply to residential complexes or industries and facilities due to a pump failure would drastically affect the work routines and daily course for all the residents and employees. In medium to large facilities, the pumps are usually housed in separate buildings, for example treatment plants, and is called the pumping station. The pumping station contains the various components of the pumping system, namely the hydraulic system, the electrical system, the control system. The hydraulic system consists of pump and related piping. The electrical system consists of the motor and its related components. The control system consists of pressure, flow and level switches. Let's now learn the various types of pumps. Pumps are mechanical devices that are used to move or displace fluids, gases or even solids from one place to another in a way that is extremely efficient and conservative to the environment. They are available in many different shapes and sizes and configurations for their multiple uses. Thus, they can be classified in many different ways, according to their method of operation, design or construction, method of conveyance of water, uses, types, etc. The example of pumps are water pumps, gas pumps, sewage pumps, sump pumps, axial pumps, gear pumps, piston pumps, and reciprocating pumps. In the field of building technology, pumps have a very important role and are used in air conditioning systems, water supply, wastewater disposal, in pressure booster stations, in fountains or aquariums, firefighting applications, cold and cooling water, rainwater utilization for toilet flushing systems, washing machines, cleaning and irrigation, among many others. Maintaining the daily operation of pumps in facilities is very important and cannot be taken lightly. Pump failures can drastically affect the production costs of a business or processes. The resulting costs from pump repairs and disruption to building operations typically exceed the cost of ongoing pump maintenance by a factor of 10 or more. Thus, maintenance activities and the frequency with which they must be performed vary with the capacity of the pump and the nature of the load it is serving. There are some basic terms that are associated with the use of pumps in the industry that needs to be understood. They are as follows. Head, a measure of pressure expressed in feet of head, or conversely, how high the pump can lift the liquid in terms of height. Flow rate, a measure of the liquid volume capacity of a pump, given in gallons per hour, that is GPH, gallons per minute, that is GPM, liters per minute, that is L per minute, or milliliters per minute, that is ml per minute. Pump efficiency, a ratio of total power output to the total power input expressed as a percentage. This ratio is symbolized by the Greek letter eta. Brake horsepower, BHP, The bhp is the actual amount of horsepower being consumed by the pump as measured on a pony brake or dynamometer. Let us now learn the definition and uses of pumps. A pump is a machine or device that can be used for raising, compressing, or transferring fluids of varying densities or viscosities, that is hot or cold, clean or dirty, from one place to another, or from a low level to a high level. To make it simpler, we can say that a pump is a device that puts energy into the water. This energy can then be expressed in either an increase in pressure or an increase in the flow rate of the water. The different physical properties of each type of liquid should be taken into consideration when sizing and selecting a pump. The most important physical properties are suction pressure, specific gravity, viscosity, vapor pressure, solids content, and lubricity. Let's now understand the applications of pumps. Other than liquids, pumps are also used to move dissolved gases, dissolved air and hydrocarbon vapors, and solids like sand, clay, corrosion byproducts, and scale. Perhaps the most common application of pumps, known as the water pump, is to transport water from one place to another and is used in residential buildings, commercial buildings, and also for irrigation of fields in agriculture, to name a few. Various types of pumps are used in most facilities and industries. They are the heart of HVAC, that is heating, ventilation and air conditioning systems, supporting the operations of the chillers, refrigeration systems, boilers and cooling towers. Pumps are also used for domestic and portable water systems, flushing water system, hydronic distribution systems, sewage treatment plants, and as a part of the fire-fighting sprinkler or hydrant system. In some industries, pumps may be used for specific production or process-related function. Other important uses of the pumps include gasoline or fuel transfers, chemical movement, sewage movement, flood control, etc. Let us note that though most of the pumps mentioned above are fixed pumps, there are submersible pumps available that are portable. Submersible pumps come handy in emergency situations like flooding, where a pump is not available nearby, or for sewage overflow emergencies. So far you have learned various types of pumps and its terms, definition and uses. Let us now learn the working principle of pumps. To understand the working of pumps, let us consider it to be a device in the shape of a box. Now, fluid enters this device or box at certain velocity and pressure. This can even be zero. When the fluid leaves the box, it does so with an increased velocity and pressure, that is energy. How does this happen? Now, consider there are rotating components inside this box, which moves this fluid by either confining it in definite volumes, that is hydrostatic, and then displacing it, or by imparting energy to the fluid by dynamic action, that is hydrodynamic, of the moving parts and increasing the velocity and pressure of the fluid. In other words, a fluid pump or hydraulic pump is a machine which transfers the energy from its moving parts to the fluid passing through the machine. The energy transferred from the pump to the fluid appears as the pressure and velocity of the fluid. Most commonly used pumps, centrifugal and axial, work on Newton's first law of motion or law of inertia, which states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. These are known as hydrodynamic pumps. Some pumps work on the principle of Pascal's law, which states that an increase in pressure at one point of the enclosed liquid in equilibrium of rest is transmitted equally to all other parts of the liquid unless the effect of gravity is neglected. In case of statics, these pumps are also called hydrostatic pumps, for example, positive displacement. We will look into these types of pumps more in detail in the next sections. The performance or efficiency of a pump is very crucial to its operations. The performance factors that need to be considered in pump selection are shown on the screen. Power and capacity. Power can be measured in horsepower rating, and the capacity is how much fluid the pump can move and is measured in gallons per minute, that is GPM, or gallons per hour, that is GPH. Thus, the higher it is, the more speedily and powerfully it will move the liquid. Materials. Pumps are made of a variety of sturdy materials, including sheet metal, cast iron, stainless steel, and other materials. Power sources include electricity, gasoline, diesel, hydraulics, natural gas, compressed air, steam, or manual. Head. Head pressure describes how powerful a pump is. Vertical discharge head pressure describes the vertical lift and height at which the pump can no longer exert enough pressure. Since there are many different types of pumps that are used in various ways, methods, and for various uses, the classification and types of pumps can be quite extensive and is beyond the scope of this module. Therefore, we will take a look at the basic classification here on a need-to-know basis only. Basically, there are three major groups of pumps according to the method of conveyance of water: direct lift, displacement, and gravity pumps. Pumps can be submersible or external. Pumps can also be broadly classified according to their method of operation as dynamic pumps and positive displacement pumps. Most commonly used pumps in industries or facilities are the dynamic pumps, that is, centrifugal type. The basic classification of pumps is shown on the screen. As can be seen in the figure, the positive displacement pumps, which account for 5% of pumps in India, can be either rotary or the reciprocating type, and the dynamic pumps, which account for 95% of pumps in India, can be either centrifugal or axial type. Let us now understand more about positive displacement pumps. As mentioned earlier, positive displacement pumps are also known as hydrostatic pumps due to their principle of operation. They operate on the principle of Pascal's law. Some of these pumps have an expanding cavity on the suction side and a decreasing cavity on the discharge side. The liquid flows into the pumps as the cavity on suction side expands and the liquid flows out of the discharge, most typically using a rotary, reciprocating, or diaphragm method to move fluid as the cavity collapses. In other words, it alternates filling a space with liquid within the pump and then moves out that liquid through another outlet, thereby displacing it. The volume is a constant given each cycle of operation, unlike centrifugal pumps. Thus, a positive displacement pump will produce the same flow at a given speed, that is RPM, no matter the discharge pressure, and therefore is a constant flow machine. These pumps are ideal in many industries that manage high viscosity liquids or where sensitive solids are also present. For example, the oil and gas industry. Let us now understand more about centrifugal pumps or rotodynamic pumps. A centrifugal pump uses a rotating vane impeller, that is fan-like blades, to produce a head and a flow by increasing the velocity of the liquid through the machine. These pumps work great within thin liquids and high flow rates and therefore are the most preferred hydraulic pumps used in the industrial and domestic world. Centrifugal pumps are generally used in pumping stations for delivering water to homes and factories. The advantages of non-positive displacement pumps are low initial cost and minimum maintenance, simplicity of operation and high reliability, capable of handling any type of fluid, for example, sludge and slurries. Let us now understand the components of centrifugal pumps or rotodynamic pumps. A pump consists of the following main components. Motor, the power source of the pump which drives the shaft. AC motors and DC motors are the most common power sources for pumps. This is the most important part of a pump. Shaft. The shaft connects the impeller to the motor or engine that provides power for the pump. Impeller. A rotating disc with a set of vanes or leaves or blades fixed to a shaft. Impellers come in a variety of types and can be either open or closed. Pumps can also be further categorized based on the number of impellers used as single-stage pump. When in a casing, only one impeller is revolving, then it is called single-stage pump. Double or multi-stage pump. When in a casing, two or more than two impellers are revolving, then it is called double or multi-stage pump. Volute. The inner casing that contains the impeller and collects, discharges and sometimes recirculates the fluid being pumped. Pumps that have a volute casing are the most common type of centrifugal pumps. Pump housing or casing. The outer shell of the pump which protects most of the components from the outside elements. The casing of the pump should be of materials suitable to withstand the environmental conditions of the application. For example, submersible pumps should be water and rust corrosion resistant. Let us now understand the working principle of centrifugal pump. Centrifugal pumps, that is dynamic pumps as mentioned earlier in this module, are also known as hydrodynamic pumps due to its working principle. They work on the principle of law of inertia, where the fluid is displaced against the resistance of the system and transferred using the inertia of the fluid in motion. That is Newton's first law of motion. Here, the pressure produced is proportional to the rotor speed. The electric motor of the pump drives the shaft on which the impeller is seated. When the motor is started, the water that enters the impeller axially through the suction port and suction neck is deflected by the impeller vanes in a radial movement, thereby imparting a centrifugal force to the fluid, which causes both the speed and the pressure to increase when water flows through the vane area. Once the fluid exits the impeller, it is collected in the volute housing. Since the impeller imparts kinetic energy to the fluid, centrifugal pumps are also known as hydrokinetic power generators. Let us now understand the top 5 manufacturers of pumps in India. The top 5 manufacturers of pumps in India are Kirloskar Brothers, KSP Pumps, Shakti Pumps, Yukin Pumps, Dynamatic Tech. So far you have understood the components and working principles of centrifugal pump and top manufacturers of pump in India. Let us now look at the steps involved in the operations and maintenance of pumps. The utilization pattern or the operational management for different pumps will be different. While some pumps may be running continuously and sequenced with others for auto changeover, the others may be switched on or used on need basis. Irrespective of the utilization, service level to be maintained for all pumps will be dictated by the relevant pressure required by the system. Additional checks may be required to be undertaken before using pumps on manual control, like checking of water level in the sump, priming of the pump, motor insulation, etc. The importance of pumps to the daily operation of buildings and processes necessitates a proactive maintenance program, which incorporates a preventive and predictive maintenance schedule. Most pump maintenance activities center on checking packing and mechanical seals for leakage, performing maintenance activities on bearings, assuring proper alignment, and validating proper motor condition and function. Some of the typical checks that needs to be performed during operation are: check pump for proper operation, check for leaks on suction and discharge piping, check for leaks from mechanical seals, gland packing, etc. Check motor and pump operation for excessive noise, vibration and overheating. Check operation of controls or gauges and record parameters where available. Clean exterior of pump motor and surrounding area. Clean strainer of suction line if applicable. Some of the typical checks that need to be performed on monthly basis are: apply lockout tagout to isolate the pump. Inspect condition of shaft seal for leaks. If required, replace mechanical seal. Lubricate pump and motor bearings. Check tightness of foundation bolts. Remove cover of motor terminal box and check all terminations for loose connections. Tighten if required. Check running load current in all phases. Remove lockout or tagout. Some of the typical checks that need to be performed on annual basis are: first step is to start the standby pump. Then isolate the pump that needs to be serviced and apply lockout or tagout to be verified before doing any maintenance work. Inspect pump for cleanliness, shaft seal or any other leaks. If there is a leak in the shaft seal, disconnect coupling and replace or repack the mechanical seal as per instructions of manufacturer. Lubricate motor and pump bearings. Check coupling for alignment and also its rubbers. Remove cover and check the terminal box for any arcing, overheating or burnt wires. Tighten if there are any loose connections found. Inspect all electrical wiring and components for wear. If any rust or corrosion found, clean and apply anti-rust paint. Open suction or discharge valves. Measure motor and record. Replace guards, covers and clean area around the pump. Remove lockout or tagout. Start pump and check amperes and record it. Put isolating switch on after carrying out maintenance. Let us now understand the work method statement for maintenance of pumps. The work method statement for each type of pump will be unique and based on the type of maintenance or reactive work being undertaken. However, the following elements should necessarily be part of the work method statement. For systems with spare pumps available, the load of the system needs to be transferred to the alternate pump. Where no spare capacity is available, change request or necessary approvals for shutting down systems are to be taken. Lockout or tagout needs to be applied for isolating the pump, electrically, that is breaker, and mechanically, that is inlet and outlet valve. Personal protective equipment, that is PPE, is to be used as required. Lockout or tagout is to be removed after completion of work and testing. Let us now understand the impact of business when there is a failure in pump. Any failure in a pump may directly impact the system it is being used for, which in turn may lead to employee discomfort, production loss, or a safety or regulatory concern. Hence, the impact on business of a pump failure will depend on what purpose it is being used for. For instance, failure of a domestic water pump for a short duration may not adversely impact the business, but a longer downtime may impact employees' well-being. For critical uses, normally additional pumps will be provided by design to avoid dependency on single equipment. The impact of failure of few typical pumps used in facilities is shown on the screen. Failure in domestic or flushing water pumps impacts employee well-being, health and safety. The failure in chiller pumps impacts indoor air temperature, employee well-being, health and safety. The failure in cooling tower pumps impacts water-cooled CRACs, business impact, production loss. The failure in fire pumps impacts fire safety and regulatory impact. The failure in pumps in industrial production or processes has business impact and production loss. The failure in sewage treatment plant has regulatory and environmental impact.
Take a look at the most common issues faced in the pumps and how to troubleshoot each. Scroll down the chart on screen to see troubleshooting ideas for the top 5 issues.
Cavitation. Cavitation is the formation of vapor cavities in a liquid, bubbles or voids, as a consequence of forces acting upon the liquid. When subjected to higher pressures, these voids can implode close to the metal surface, resulting in a surface fatigue of the metal and causing a type of wear called cavitation. Cavitation can usually be avoided or stopped by simply increasing the pressure of the liquid before it enters the suction nozzle of the pump. Congratulations! You have now completed this e-module on pumps. In this e-module, you learned the following. What is pumps and its uses? Working principle of a pump. Classification and types of pump. Positive displacement and centrifugal pumps. Components of a centrifugal pump. Top 5 original equipment manufacturers. Operations and maintenance of pumps. Work method statement for maintenance of pumps. Impact on business. Top 5 issues or troubleshooting ideas.